Okay, today we talk about regular expressions. So regular expression is a pattern to be matched against the string. It's essentially a pattern matching. So Bill, B-I-L-L, is the pattern that matches the four letters B-I-L-L. But there are more expressive and powerful patterns. Matching either succeeds or fails. Sometimes you want to not only match it, but also perhaps do something with the match, replace a pattern with another string. So regular expressions are very useful. They're used by many commands, such as grep. Grep is the command for searching for a string in a file or a collection of files. We learn how to use grep with a literal string. You can search for the word Bill in any text file, but as we learn, we can also use a regular expression. So you can search for very complicated patterns in a file, not just the literal string. The others we haven't learned, so we won't discuss yet. These other commands. If you're looking for all the lines in the file that contain the string Shakespeare, you can use grep followed by the string, followed by the file name, and redirect the output to an output file result. So here, this string here is the regular expression that grep is looking for in the file movie, and all the lines that match are redirected from stdout, which is the display, to a file called result. So in Perl, so that the grep command here is a shell script, shell command. But if you want to use regular expressions in Perl, you enclose the expression with slashes. So here, this is strange, right? If regular expression. So you're testing the regular expression against the string. So where's the string? Remember that whenever you omit the string argument, it's always the default $_. So this is checking the regular expression against $_. When a regular expression is enclosed in slashes, $_ is tested against the regular expression, returning true if there's a match, false otherwise. We will see later how you can test some other string not $_. You have a command called equal tilde, which lets you test regular expression against any string. If you omit this command, it tests the against $_. So this tests only one line because $_ is a string. So strings are terminated by new lines /n. So anything after /n starts a new line. So therefore, this one if statement tests one line only. If you want to test all the lines, you must add a loop around it. So this says read the file or input line by line and do something with each line, and until you reach the end of the file, end of the input, which is Control D if you're using standard input. So print here, you say print without an argument is equivalent to print $_. In case you forgot, let's review how file I/O works. No, I think it's for I/O. Yeah. So you can read from stdin with while stdin do something with $_. So this statement reads a string, a line into the string $_. If you just say less than greater than without the stdin, it can read a single line from either a file you specify on the command prompt or the stdin. So here you say while less than greater than print, and you invoke the script as mycat f1, f2. It'll read f1 and f2, these two files, and print each line as a string, including all the new lines, because the line includes the new line itself, unless you do a chunk, which removes the new line. So here it says while this guy, then what this does is that it pulls out one line terminated by new line /n and place it in this variable as a string. And if tests this regular expression Shakespeare against this string $_, and if it matches, then it's a true. You print the string. Otherwise, you don't. You go to the next line until you reach the end of the file for input. So Shakespeare is a long word. So if you don't know how to spell it, you can say, the first four letters are shack. Last letter is R, not the last, but somewhere near the end there's an R, and a bunch of letters in between. So this regular expression says dot represents any letter, any character, and star means that repeat the preceding character 0 or more times. So $* means 0 or more of any character. So this regular expression says this string must start with shak and followed by 0 or more characters, any character, followed by R, and perhaps something after R also. Or even something before shak, that's fine too. So this will allow you to match any string, that is any line, with say shakr. It's a match. Shakabcr. It's also a match. shakre is also a match. So it matches more strings than Shakespeare, but it definitely matches Shakespeare. So if you do it on the command line, you must add double quotes around the regular expression, because otherwise the shell will interpret star as all files. Remember, ls star lists all files. So But the quotes are not necessary in the Perl script. It's only necessary in the shell script. So perhaps you think you should do this. You should follow R with dot star because there's the E after R in Shakespeare. So no need, because any character can come before or after the pattern. So this regular expression is the same as if you precede or postpone the dot star before or after the string. So it will match essentially a fragment with this early expression preceded by any characters and followed by any character. So you can omit the dot star before and after the string, and it wouldn't affect the regular expression correctness. So another expression is substitute operator. That is, sometimes you want to match something, you look for it, but you also want to do something with what you found. Perhaps you want to replace Shakespeare with the string Bill Gates. So this regular expression says substitute Shakespeare with Bill Gates. So again, dollar underscore is the string to be matched. So these two are patterns. The string to be matched is implicit in dollar underscore. If the match is successful, the part of the string that matched is discarded and replaced by the replacement string, Bill Gates. If the match is unsuccessful, nothing happens. So that is, if the string doesn't contain Shakespeare, then this regular expression has no effect. So you can think of it as in your word editor, you have the search and replace command, right? Except I think search and replace in Word doesn't allow you to specify regular expressions. You can only specify strings. It's less powerful than this. So here, if you enclose the this if, so this if says given a string stored in dollar underscore, match it against Shakespeare. If this string contains Shakespeare somewhere in the string, you substitute Shakespeare with Bill Gates and print out the resulting string, dollar underscore again. Now this if block works on one string only. So if you enclose the if with this while, which means that you read in each line and place each line as a string into dollar underscore, and then work on this string within the while loop until the end of the file. So this will process every single line in your input file. So here you have the file with 4 lines. So the first line, you read in Titanic. Actually, the line contains Titanic's /n because it's a new line. It didn't do a chunk, right? So there's a new line there. In fact, if you did a chunk, this thing will still work, except you print out everything on one line. So Titanic doesn't have Shakespeare, so if the regular expression Shakespeare doesn't match against Titanic /n, therefore if returns false. So you skip the if body and go on to the next line, saving private line /n. which doesn't match Shakespeare again, then go on to the next one, Shakespeare in love. You match, you go into the body of the if and substitute Shakespeare with Bill Gates and print Bill Gates in love. Now dollar underscore has been modified within the if body. And finally, the next line doesn't match, so you reach the end of the file, you get out of the while loop. So the result is Bill Gates in love. So a shorter way is just to say if substitute. So in the previous program, we checked if the regular expression matches or not. If it matches, then we substitute the regular expression with another string. But here we can simply say substitute. This command will return true if the substitution is successful, and false if it fails. If it fails, that is, if there's no such string as that matches Shakespeare. So it has the same effect as checking the match and then do a substitution. Because the substitution can only fail if the match fails, right? The regular expression is a pattern. So some parts of the pattern match a single character. Some parts match multiple characters. So if you say A, it will match the literal string A. Small a, that is. It matches nothing else. But if you say dot, it matches any character. It's so-called wildcard. So followed by a star, it matches 0 or more repetitions of any character. So if you say A star, it'll match 0 or more A's. So dot matches any single character except the new line. So doesn't match the new line. So A star, A dot matches any two-letter sequence that starts with the A and is not a new line, because dot doesn't match new line. So it matches AB, AC, A equal to, or A anything except a new line. So if you really want to match a period, you can use the escape character backslash to say don't treat dot as special, treat it as a literal dot. So this guy says if regular expression enclosed in the two forward slashes, you have the regular expression slash dot. So it'll match a literal dot, not any character, because I have a slash in front of it, backslash. And also anything before and after is fine. So it'll see the first line, hi, doesn't have a dot in it, so it skips the next line, hi Bob, dot. So it matches the dot. There's a hi Bob in front of it, that's fine. Anything can come before or after the regular expression, it's still a match. So it matches the line hi Bob, dot. So remember the prints the dollar underscore, which is the complete string, not just the part that matched. So it prints out the whole line, hi Bob dot, and a slash and a backslash n, because you didn't do a chop. If you want to specify one out of a group of characters, you say a square bracket. So this says match any one character of the 5 A, B, C, D, E. So any one of the 5 lowercase letters. If you say this, it says match any one of the 10 letters. They happen to be vowels, so match any vowel, whether lowercase or uppercase. The order doesn't matter. If you say small a, big A, small e, big E, it doesn't matter because it's simply a list of letters. So what if you want to match right brackets? Not use it as a enclosing delimiter, just treat it as a literal right bracket. So obvious way is to use escape backslash. You say this. This means that match any one of the characters A or B or C or D or E or right bracket. Or you can say this. This says the first pair of brackets enclose 5 letters. The last one is a real bracket. So match any one of the characters here plus a bracket. So it matches A bracket, B bracket, C bracket, D bracket, etc. Or this guy says match any one of the characters among A, B, C, D, E, and right bracket. It'll match A, B, C, D, E, and bracket. So this is the same. These two are the same. So theoretically, you should put a backslash in front of the right bracket here, but it's really a shorthand. If you place the right bracket at the first character in the list, you can omit the backslash. The first one is different, right? First one matches 2-letter words. One letter A, B, C, D, E followed by a bracket. So dash matches ranges of characters. So if you want to match any single digit, you can say this. Square brackets 0, 1, 2, 3, 4. So you can write, or you can write simpler. You can say 0-9. So we saw this before, right? So this means ASCII character range. That is, you cannot say 0-11. It doesn't work. It'll say 0-11 essentially means 0 to 1 plus additional 1. So it doesn't know any numbers. It only knows the ASCII sequence of the digits of the letters. So we can say X-Z matches XYZ in the ASCII order. So each letter has an ASCII code, right? If you recall. So if you really want the dash in the list, you want to match a dash. You don't want to treat it as a range. So you can use the backslash to escape the dash to mean that I really want an X or a Z or a dash. Or if you say this, the dash is after the Z, it'll also mean X or Z or dash, or before the Z, before the X. So only when it's in between two characters, then you treat it as a range. So 0-9 So this means match any letter 0, 1, 2, 3, 4, 8, 7 until 9, or a minus, a dash. So because they're enclosed in the square brackets, it is the OR relationship, right? If you don't have the square brackets, it means append, right? So in the previous result, this example, so here this guy means any one of A, B, C, D followed by a back quote, by a right bracket. But here we say, because we have the square brackets around the string, we say it's any one of 0 to 9 or a dash. So it's 0, 1, 2, or a dash. So the next one says any digit or lowercase letter. That is any one 0, 1, 2, 3, 4 until 9, or A, B, C, D until Z. So, and this whole thing matches one character only, either a 0 or a 1 or a or a Z, etc. So this it just says match any letter, lowercase or uppercase, or any digit, and or a underscore at the end. So to remember anything inside the square brackets, you always pick one, exactly one, out of the thing inside the brackets. So you can have the a little hash immediately after the left bracket. It means that negate the regular expression. So this means match any single non-digit character. So 0, 1, 2, 3, 4 until 9 matches any single digit. You prepend it with a hash just after the left bracket and just before the pattern. It will negate the pattern. That is, match anything that's not a single digit. So that is any single non-digit. This one is the same. So this one says match anything that's not one of A, E, I, O, U. That is any single non-vowel. Either a B, D character or any other character, like equals or dash or underscore, anything will match, except all these characters here. So this guy, you have the escape in front of the second hat. This means that treat the second hat as a literal hat. So, and the first hat negates this regular expression. So it means that match any single character that's not a hat. So there are some predefined character groups for your convenience. You don't really need this because you can express, say 0-9 matches any digit. You can use a shorthand, a \d, to mean the same thing. And \w means this thing. It means that any letter, digit, or underscore. So it's very useful, especially when you are working with a program in Java or C++. It will let you parsing easily. So per is regular expressions are widely used in parsing files. So you can parse the file into tokens based on regular expressions. So small s means space character, which means that a space, this is a space, or a tab, that is the tab on your keyboard, or a new line. So all these are treated as white spaces and matches \s. So uppercase letters indicate negated. So big D means this, not a digit. \big W means not one of those. And this guy means not a white space. So this one here matches \D, that means any digit followed by no, not followed. This means that pick anyone out of the group, either any digit or any lowercase letter or any uppercase letter. So it matches any hexadecimal digit. So what's the hexadecimal number? It looks like say 6 F or 7D or something like that. So if you want to match one of the digits, one of the characters in the hexadecimal number, so it's either a digit or a letter, lowercase or uppercase. So again, remember that this whole thing enclosed in square brackets takes out one character out of this pattern. Multipliers allow you to say one or more, or up to how many? 4. So star means 0 or more of the immediately previous character, or character group if you have parentheses. So if you say A star, it means 0 or more A's. Dot star means 0 or more of any character. So plus means 1 or more of the immediately previous character. Question mark means 0 or 1 of the immediately previous character. So say A question mark will match a null string or a single A, but it wouldn't match double A. While star and A star and A plus will both match double A or triple A. So this means a G followed by 1 or more A's, followed by T, followed by optional E, that is 0 or 1 E's. Question mark means 0 or 1. Followed by S. So perhaps you match G, A, T, S. This will match, say, G, A, T, E, S. Will also match, say, G, A, T, S. Will also match. So these star, plus, and question mark are greedy, will match as many characters as possible. So if you have a string like this, say you match, so S means substitution. Substitute X plus, that is one or more X's, with the word cheap. So it will give you real cheap case. That is, it will substitute this whole string with the word cheap. Because plus is greedy, it will match as long as possible. So it will match the whole many X's. It won't stop in the middle. So how do you say 5 to 10 X's? So this is one way. 5 X's followed by 0, 1X, 0, 1X, 0, 1X, 0, 1X. So 5 mandatory X's followed by 5 optional X's. But it's very ugly. So it's a shorthand that says X, curly braces, 5 to 10. It means that repeat X 5 to 10 times. So if you omit the second argument, this says 5 or more X's, no upper bound. If you omit the comma, this says exactly 5 X's. If you say 0 to 5, you say X, curly braces 0, colon 5, comma 5, so 0 to 5X. So this is more precise than plus, star, and question mark. So if you have this, you can really plus, star, and question mark are all redundant, but they are there because they're widely used. So they're shorthand for, you don't have to write out, say X, curly braces 0, comma 1 to represent question mark, X question mark. So C followed by any 5 characters which can be different and ending with D. So this says that. Comma, a colon, a dot matches anything. 5 means that 5 dots. And they don't have to be the same. So you can see C, A, B, C, D, D, or equal, underscore, slash, T. So anything will match.
Match 5.
Yeah, 5 of those. As long as you have 5, except except a new line, because new line indicates string boundaries. So it's not treated as a regular character. So star is the same as 0, comma, nothing. That is 0 or more with no upper bound. Plus is 1 or more. Question mark is 0 to 1. So how do you match a pattern that starts and ends with the same letter or word? So you need to remember the pattern and match it later. So use the parentheses around any pattern to put that part of the string into memory. It has no effect on the pattern itself. It simply remembers the part of the string during the pattern matching process and try to match it again when you process the latter part of the string. So to recall memory, include the backslash followed by an integer. So this says Bill followed by any character followed by Gates, followed by the same character you saw before. So this will match because Bill exclamation mark then the dot here matches the exclamation mark. Because you have a parenthesis around the dot, you remembered it. So you remember the dot represents an exclamation mark. So when you do this \1, it means that match the exact same thing you saw before in the first parenthesis. So if there's an exclamation mark here, you must have an exclamation mark in the end. If you have a dash here, you must have a dash in the end. But not different. If you say this guy doesn't match, and this doesn't match, because these two are different characters. So it matches a string starting with Bill, followed by any single non-neuron character, followed by Gates, followed by that same single character. So just remember, parentheses indicates memory, and you refer to the memory with \1, \2 as the first parenthesis, second parenthesis, etc. So this guy, Bill dot, Gates dot, will match all the four of these. However, these two dots do not need to refer to the same character. So it is different from this regular expression here. So this guy, the later one has no memory. So these two dots can refer to anything. It will match all four. So this one matches a string that starts with an A, followed by a character, this guy, followed by a B, followed by another character, followed by a C, followed by the second character. So the character following C must match the second parenthesis, and followed by the first character. These two must match. So this guy is okay because these two match and these two match. Right? So the reference can have more than one single character if you enclose an arbitrary string in the parentheses. If you say here, it means match an A followed by any number of characters, even zero number of characters, followed by a B, followed by the same sequence of characters, \1. It refers to the whole thing inside the parentheses, followed by a C. So this guy, A bill, B bill, C, matches the regular expression because these two are the same string. ABC also matches because these two are two empty strings. Because star means zero or more. You can have zero characters in the parentheses, which means it's an empty string. Then you must have an empty string between B and C also. But not this one, because Bill is different from Bill Gates. So the thing between A and B is different from the thing between B and C. So if there's more than one character in the patterns, if you want to select among 3 choices, Gates, Clinton, or Shakespeare, you say this. Vertical bar to separate the choices. So this guy, A vertical bar B vertical bar C is the same as square brackets A, B, C. You pick one out of A or B or C. But vertical bar is more powerful because it allows you to pick among strings instead of just among single characters like in a square bracket. So anchors requires that the pattern be at the beginning or end of the line. So hat matches the beginning of the line. So this means that match lines that begin with bill. So if you simply say slash bill, it'll match any line, any string that contains bill in it. Anything can come after bill. But if you say hat bill, it'll match the string that begins with bill. Nothing can come before bill. But things can follow bill, that's fine. So similarly, hat gate means anything that begins with the word gate. So this one, because you have escape in front of the hat, it means that match the line that contains bill, hat. Hat is treated as a literal character here. And this one, because you have a hat with a backslash, it means that match lines containing a literal character hat. So don't confuse this with the hat in front of within the square brackets. If you say hat ABC square brackets, it means that match string that's not one of A or B or C. But without the square brackets, it means the beginning of the line. There is nothing in front of the pattern to be matched. So dollar is the symmetric thing indicating end of the line. So only if this guy dollar is the last character of the pattern. So bill dollar matches lines that end with the word bill. Nothing can follow bill. Gauge dollar matches any line that ends with gauge, any string that ends with gauge. And dollar bill will match contents of the scalar dollar bill. So here dollar, because it's not the last character of the pattern, it doesn't indicate end of the line. It simply indicates a variable, a per variable, which is a scalar, because it's a dollar sign. If it's an at sign, it means it's an array or list, but dollar indicates a scalar. And this guy says match any line that contains the contents of dollar bill. Perhaps dollar bill contains another string, it will substitute the string in the regular expression and match it against a line. So this one matches lines that contain dollar. Remember, backslash always indicates escape. So treat the dollar here as a literal dollar sign. So if you say, for example, hat bill dollar, it'll match the line with a single bill. Nothing in front and nothing after bill. If you say hash dollar, it will mean match the empty line, empty string. So if you have this pattern, so you treat it as parens A bar B and then star, or A bar B star parens. So this is the operator precedence constraint. So the order is parentheses has the highest precedence, it overrides anything, followed by multipliers, followed by sequence and anchoring, that is beginning or end, followed by the alternation, that is vertical bar. Therefore, star has higher precedence than vertical bar, so this one is the correct interpretation of that pattern. So this means either A or 0 or more B's. So if you want other interpretation, just enclose this thing in parentheses if you want to override the default precedence relationship. So use parentheses in ambiguous cases to improve clarity, even if it's not strictly needed, just like in your daily programming. So we learned that parentheses indicate memory, right? If you enclose something in parentheses, it goes into memory, into /1/2, indicating the thing inside the first, second parentheses, etc. So parentheses for precedence is no exception. So any parentheses will make the part inside of the parentheses go into memory. So just keep this in mind when you are counting. Perhaps you're counting which memory element refers to which parentheses. You must count all the parentheses. So this guy means match A, B, parentheses, and then C star. So matches A, B followed by 0 or more C's. So this one means matches 0 or more ABCs. So empty string matches 0 instances of ABC, or 1 ABC, 2 ABCs, etc. So this one matches A at the beginning of a line or B anywhere. So it's either hat A or B. So this one means match either A or B at the beginning of a line. So any line that starts with A or B will match. So this one means match either A or the string BC or D. This one means match either A or B followed by either C or D. So it's AC, AD, BC, or BD. So this one matches the string Bill Gates or the string Bill Clinton. So this one matches the string Bill followed by either Gates or Clinton. So in effect, these two are the same. So this one matches Mr. followed by a literal dot. Because you have escape in front of the dot, it doesn't match any character anymore. It matches the dot character. Mr.Bill, or this thing inside the parentheses says Bill followed by either Gates or Clinton. And then you have a vertical bar indicating that it's either the thing before the bar, Mr. Bill, or the thing after the bar, that is Bill Gates or Bill Clinton. So this one says you have a Mr. dot question mark. So that is 0 or 1 Mr. dots, followed by the string Bill, followed by either Gates or Clinton, repeated 0 or 1 times. So Bill will match because both of these question marks indicate 0 instances. So Bill preceded by 0 Mr. Dot and 0 Gates or Clinton. Mr. Bill will match, that is 1 Mr. Dot. Bill Gates will match, that is 0 Mr. Dot, followed by Bill, followed by 1 Gates. Bill Clinton will match Mr. Bill Gates and Mr. Bill Clinton. Right? So up to now we have been using the default variable $_. If you want to use another variable, you want to match it, say, against this variable, $name, a scalar variable that you assigned earlier. You use this equal tilde. So this means that match the pattern after the equal tilde to the string before the equal tilde, and if the match is true, this whole expression returns a true value. Otherwise, the whole expression returns a false. So name is a string, Bill space Shakespeare. You do a match with #Bill because the string starts with the word Bill. It matches. This guy says match any single character dot followed by the same character, because you use the parentheses to remember the character, and then you use the \1 to refer to it again. So it must be repetition of the same character. So it also matches because LL is a repetition. Nowhere else you have repetition. So you can use if, because if the match is successful, this whole thing returns a true. So and then print the string if it matches the expression. You can also match against stdin. So this expression says any string that starts with a y, capital or lowercase. So if the stdin, if the string you read in from the standard input, if it matches this pattern, then you can exit. Print quitting and then exit. Otherwise, you skip the if body and print continuing. If you run it, it'll ask you quit. Yes, no. If you type in big Y or small y, it'll all exit. Otherwise, it will say continuing. Notice the difference. If you say square brackets hat small y big Y, it means something different. It means negation of the pattern, and that's something a character that's not a small y or big Y. But if you have the hat outside of the square brackets, it means that this response starts with a Y. You can type in yes, it'll also match. So also you can read in the input explicitly assign it to a string, or you can simply say use it as a string in itself and match it directly against a regular expression. So in the previous example, you only do it once, right? Either yes, you say quitting, or no, you say continuing. In either case, this program exits. You have an explicit exit here, but if you execute print continuing, it naturally exits. If you want to do a loop, you must have the while around this signal wake up. So while the stdin is, if it matches any line that starts with a small n or big N, then you go into the while body and print sleeping, and then prompt the user to say wake up or not, and until the user enters something other than small n or big N. And then the stdin doesn't match the regular expression, and this whole thing returns false. This whole thing returns false, and then you exit the while loop. So you can say no or simply N. It'll all match this regular expression and cause the loop to be repeated. But if you say Y, well, anything that's doesn't start with an N. If you say bad or A or anything, it'll all cause the loop to exit. So we used small y big Y or small n big N to match either upper or lowercase letters. You can say some pattern followed by /I to mean ignore case. So here you say match any line that starts with a Y, ignore case. That is, if it starts with a small y or big Y, they both match. You quit. Otherwise, you do say continuing. So it is the same effect as square bracket, small y, big Y. So it's really a shorthand. So if your pattern has a slash, say if you want to match this string here, slash /user /local /bin, you must use the escape / to precede each / to indicate that it is not a special delimiter, because you have the two slashes, / at the beginning and end to indicate the delimiting the boundaries of the regular expression. So if you want the a literal forward slash inside of the regular expression, you must precede it with a backslash to escape it. So this means that match any string that starts, you have a hash here, starts with this string, literal string, user local bin. Can be followed by something else, slash something, that's fine. If you want to match exactly this string, you should say hat in front and then dollar after. So to make it easier, if your pattern has a lot of slash characters, you can use a different pattern delimiter with M followed by any non-alphanumeric character that is not a digit, not an alphabetical character. So pound is okay, pound is okay, add is okay, underscore is okay, dash is okay. Anything that's not an alphanumeric character can be used as a delimiter as long as you have an M in front of it. So this says match any string that starts with user local bin, because you have the pound as the delimiter, not the default forward slash. You don't have to precede the forward slash with backslash to escape it anymore inside of the regular expression. So this one also works. Of course, if you want to have, say, a real pound, literal pound inside of the regular expression, if you use pound as the delimiter, you must precede it with a backslash. So after a successful pattern match, these variables $1, $2, $3 are set to be the same value as /1, /2, /3. You can use them later in your program. So here's the string. Here you match it against this regular expression. Because this string is $_, you don't have to say equal tilde to do the matching. Because without it, it uses $_ by default. So it matches any W. W means any alphanumeric character, I believe. Yes. Small w means any A, B, C, D, E, or 0, 1, 2, 3, 9. So W star means match one or more of the alphanumeric characters, followed by big W means non-alphanumeric characters, which means space or dash or plus or anything. One or more non-alphanumeric characters followed by one or more alphanumeric characters. So this guy will match, the first W plus will match Bill, second big W plus will match the space, and the second W plus will match Shakespeare. So because you have the parentheses around these two patterns, so the first one is stored in \1. Second match is stored in \2. They're also stored in $1, $2. If you want to use it outside of your regular expression environment, you can use it just like regular variables. You can say the first name is $2 is $1. It'll say first name is Shakespeare is Bill. Whilst \1, \2 can only be used inside regular expression to do further matching, while $1, $2 can be used anywhere in the Perl program. You can also explicitly assign the variables. Say this one means match this regular expression against $_, and then store the resulting variables from the parentheses into this two scalar variables. So it'll store $1 in first as Bill. That is the first parenthesis. And the second parenthesis, which matches Shakespeare, will be stored in last. So it'll say the first name of the last, Shakespeare, is first, which is Bill. Of course, in this case, you happen to have two parentheses and two variables. If you have, say, three parentheses with two variables on the left, then you match the first, assign the first two parentheses to the variables and throw away the last. If you have less parentheses on the right than the variables, then the variables get non-def, undefined. So other $ampersand means the part of the string that matched the pattern. So this guy means match this regular expression. What is this? This is space in space. So it'll match this part of the string. Therefore, $ampersand will contain space in space. That's $ampersand. And single backquote matches the part of the string before the match. That is Bill Shakespeare, and single quote matches the string after the match. That is love. So these are built-in read-only variables for your convenience. Can we replace all matches instead of just the first match? Use the G, which means global, during substitution. So you have the string $_, and then you substitute Bill with William, substitute the first part of the regular expression with the second part of the regular expression. So what you get is to substitute the first Bill. You get William Shakespeare in love with Bill Gates. The second Bill is not substituted. Now, if you reassign the string and say substitute followed by a G means global, then you replace both Bills with William. So now you have William Shakespeare in love with William Gates. G means that you substitute everything in the string. So suppose you have a file, then this G only has the effect of globally on the same line, that is in the same string. If you want to do a global replacement in the entire file, you must have while less than greater than around it to iterate over all the lines. So a new line is this separator in regular expressions. So anything separated by new line are treated as separate strings. Variable interpolation. So you can assign two variables, find and replace, and then use these variables in the substitution. Substitute find, $find, which is Bill, with $replace, which is William, globally. And then you get the same effect, substituting these two bills with William. So this one, you match one or more alphanumeric characters, remember it, store it in \1 or $1, and then replace the string surrounded by less than and greater than. So $1 matches this thing inside of the parentheses, and you add additional angular brackets around it. So it will match BILL as the first match in the parentheses, because \W matches alphanumeric characters. So \W plus will match up to BILL. It won't match the space after Bill. The space is matched by big W, which is not in here. The next match is Shakespeare. So your first match, you replace it with the same string surrounded by angular brackets. Second match, you surround it with angular brackets, and so on. And all the spaces are intact. They're still there. So the effect is this. So here, if you say \1 instead of $1, it has the same effect. So substitution allows you to ignore case. So here's the line string, and here's you match it against this expression. So you substitute Bill with William, and then substitute Shakespeare with Gates. You get William Gates in love with William Gates. So So let me see. So I here means ignore case. G here means globally. We place every instance in a line, and you happen to use pound and at instead of the forward slash as the delimiter. So this means that replace any Bill with any William. Replace any Bill, whether big B or small b, ignore case. And this one means substitute any Shakespeare, ignore case, with the word Gates. So split allows you to break a string into fields. So you have a string here. You split at fields is an array variable because it's an at, right? Dollar is a scalar, at is an array. You split it using the white space as a separator, and then assign the result of the split to the array fields. So it takes the regular expression and the string and breaks up the line wherever the pattern occurs. What is the pattern? It's an empty space. So it'll break up Bill as the first element, zeroth element of fields, Shakespeare as a one's element, in as the two's element, and so on. And then print out 0, 3, and 6 elements of fields. You get 0 is Bill, 3 is love, and 6 is Gates. Of course, you can have different delimiters. You can have, if you have, say, a string is like a Bill back, a forward slash, Shakespeare forward slash in love, you must say split, slash, forward slash, and then this guy. So this means that match any forward slash and use it as a delimiter to break up the line. So you can also say split with nothing as its argument. So it looks strange. It uses the dollar underscore as the default and space as the default delimiter. So if you simply say split without any arguments, you are saying split the dollar underscore string with the space delimiter. You get the same result. Join allows you to, you're given the array variable with a list of entries. You say join and assign the result of the join to a scalar variable, line. So the result is that you get these elements of the array joined together, separated by this separator here, which happens to be a space. You get Bill space Shakespeare space this likes space Bill Gates. So here the glue string, that is the first argument to join must be a normal string, not a regular expression. You cannot say dot star or anything like that. You must say a literal string. One space, two spaces, they're both fine. On the website, I placed 2 extra links. So one is the entry on Wikipedia. With a whole bunch of examples. So we can go through some of those, and perhaps you can go home and work these out. So this one, string 1 equals hello world, new line. If string 1 matches this one, so this guy says 5 dots. So if dot matches any character, 5 dots matches any 5 characters. And then anything can come before or after the 5 characters. So the result is that string 1 has length greater than or equal to 5. So any string with more than 5 or exactly 5 characters will match this regular expression. We have the and here, so and means match as opposed to s, which means substitute. So we can omit the and. As in the lecture notes, we didn't have the and, but here he used the and in front of the regular expression, which means match. So parentheses groups a series of pattern elements to a single element and remembers them. So this one says match big H followed by any 2 characters. Remember it in the variable $1 or \1 followed by a single character followed by a O followed by any 2 characters remembered in $2. So as a result, $1 contains HEL. The first match, H double dot. The second $2 matches O space W. Right? Because it says H dot dot and then a dot, then an O double dot. So this O must match this O space W, not the O afterwards, because of the constraints in front of the O. Plus matches the preceding pattern element 1 or more times. So small m is match L plus. It means match 1 or more repetitions of the letter L. So it'll find this one as a match and then return it true. Actually, it'll also find this one, single L, is also a match, but it wouldn't even go there because the first double L will already cause this match to succeed. So it'll exit and return it true after the first double L. Question mark means match the preceding pattern elements 0 or more times. So H dot, H followed by any character repeated 0 or more times, followed by a E. So it'll match. HE will match because dot question mark can repeat it 0 times. So HE will match. HOE will also match. So for this example, this will have a HE here. Therefore, this thing returns true. So it gets tedious. There's another link, which is from another professor's teaching material. I thought this one would be interesting to explain. Run a Perl program to create a student record in the form used as input to the program. So you have this program as input as this. Name equals Joe student, test 1 equals a score, test 2 equals score, homework equals some score. This 4 lines is a single record for a student. These following 4 lines is the record for another student. You all take this file and generate another file that looks like this. Joe student tab 86, which is the test 1 score, tab 77, which is test 2 score, tab 33, which is the homework score. Next line, Jane Smith 98, 35, 85. Now you know how to do this in C. But to do this in Perl, it's actually very easy if you know regular expressions. So here's the program. We know this already. Add lines equals angular brackets. Reading all the lines in the file until the end of the file, put it in an array variable called add lines. Chunk it. Remove all the new lines. Concatenate everything into a single giant string. Because regular expression matching works on a single string. Remove the junk from each line. So this guy says hat equal means that not a equal. So it matches any single character that's not an equal sign. Plus means 1 or more. Right? 1 or more non-equal character followed by equal. Next equal. Followed by backslash means a space character, means a white space, either a tab or a new line or a space, followed by dot star. That is any number, 0 or more characters, any character. So what this does is it matches essentially it matches this whole thing. That is named is the non-equal sign character repeated one or more times, followed by an equal sign, followed by a space. And then the thing inside of the parentheses dot star matches the actual student name. It matches the Joe student for this example. And it remembers it by placing a parenthesis around dot star and uses it later to replace the whole string, \1. It means that for this example, you are replacing this line here by you remove name space equal space in front of it and only leave the part after the equal space. Only leave Joe student. That's the effect of this statement. Substitute is first part of the string with the second part, which is the student name only. Now, loop over all the lines, handling 4 at a time. So here you're looping over the so $, $pound lines is the index of the last element of the line's array variable. You have 8 lines is equal to 7, right? So from 0 up to $, pound lines and go up 4 at a time. 4 variables at a time. Join lines. Remember this array variable syntax? This means that from the ith element to I plus 1 to I plus 2 to I plus 3's element, you have 4 elements. Join them together with the separator tab. And then follow the whole thing with a new line. So as a result, this for loop here essentially grabs every single line and removes everything that's before the equals and including the equals. Removes names equal, only leaves Joe student. Next one only leaves 86. Next one only leaves 77. And then the next for loop iterates over all the elements of the array and join them together with a tab, right? And every 4 lines you add a new line. So as a result, you get Joe student tab 86, tab 77, tab 33 new line, and then another 4 entries. Jane Smith 98, etc. So notice this one has a I think it only matches. It only allows 1 space in front of the student name. Say if you say name equals double space Joe student, I think it doesn't work because \s only matches a single white space. You can try it out back home. I think it doesn't work for multiple white spaces. So, any questions on this example? All right, I want to show you something that's regular expression tester. So this is an online tool. So you can match, you input a regular expression here, input a string here, and you do a test match. If it's successful, it tells you successful match. And you can show match. And it tells you where it matched and what string matched. So you can use it to test regular expressions. So for example, here you say this is T followed by any A to Z. We didn't learn backslash D, right? Yeah, I think it's another keyword. So it matches this string. Let's see. Yeah, backslash B matches a word boundary. So it says LLO backslash B means that a word that ends with LLO. So if you have dollar, it means end of the line. If you have backslash B, it means match the end of the word. So this example, so it says match T followed by any letter from A to Z repeated one or more times, and it must be a word boundary before and after it. So T essentially it matches any word that starts with a T. So anyway, I'll put a link to this point on the website. There's a paid version, which you don't need. This is a free version, works fine for us. So, okay. See you next time.